to the next question that we said we'd do. I said I'd do. So I've looked at F, let's look at H. Again, it's the same idea. We're given all the measurements. We've got to find the centre of gravity, and then if that shape is allowed to suspend from a point P, what angle will this line here, PQ, make with the vertical? Okay, so I've drawn the diagram out there. There it is. So let's go through. Again, the law of moments to apply that shape and get the centre of gravities. So I'm going to divide it into 3 manageable pieces. So I'm going to make 3 rectangles. I'm going to call them A, B and C, and then I'm going to use the law of moments. So again, I've got forces, I've got the positions for the centre of gravity of each of those shapes. I've got the moments about the x-axis and the moments about the y-axis. I'm going to get all those things. Right, I've got 3 shapes, A, B, C. Let's find the areas of each one. Again, I'm using force per unit area for forces. So this one is, the whole height of that shape is 4 units. So 1 by 4 will give me 4W for that force. B, and I'm taking my x and y axis, my imaginary x and y axis, to be along there, along here for my x-axis, and down through PQ for my y-axis. So this will be the origin here, that position where Q is. Right, so this B, its area is 1 by 1, so that's just 1W, and the area of C is 1 by 4, so that's 4W. Okay, the positions of the centre of gravity for A is going to be 1/2 along and 2 up, so that's 1/2, 2. B is going to be 1 along plus another 1/2, 1.5 along and 2.5 up. So 1.5, 2.5 for that position. And C, likewise, if I do the same kind of thing, it's going to be 2.5, 2. Okay, the moments then about the x-axis for A would be 4W times 2. That's going to give me 8W. 1W by 2.5 will give me 2.5W, and 4W by 2 will give me 8W. If I do the moments about the y-axis, I'm going to get 4W by 1/2, which is 2W. For B, it's going to be 1.5W, and for C, it's going to be 2.5 by 4, which is 10W. Okay, I'm going to get the resultants of them all. So this one's going to be 9W. When I add the moments about the x-axis, I get 18.5W. And when I add the moments about the y-axis, 13.5W. Don't know where the centre of gravity is, I'll just call that xy. Okay, let's get the moments about the x-axis. And use the law of moments. So the sum of the moments about the x-axis is 18.5W is equal to 9W times y, the moment of the resultant. Y is equal to 2.06. W's are cancelled. Moments about the y-axis, I'm going to say the sum of the moments, which in this case is 13.5W, is equal to the moment of the sum about the y-axis, which in this case is 9W times x. In that case, then x is 1.5. So my centre of gravity is 1.5, 2.06. Now, if that shape then was allowed to swing about point P, what angle does it make with the vertical? What angle there does PQ make with the vertical? So that's what I'm after. Remember, my centre of gravity is 1.5, 2.06. So 1.5 out, 2.06 up would be somewhere around the B, in the B's shape, somewhere in here. So I'm going to mark it there, in that position. So I know where it is. It's 1.5 out, 1.5 out, and 2.06 up. So if I mark this as 1.5 out, 2.06 up, or if I just say 2.1 for convenience sake here, just for this sum, 2.1 up, that will give me this distance here, which of course is 1.9. So now I'm just going to remove that triangle. This is the bit I want, so I'm going to remove this triangle here. That's my 1.5. This is that red part there, and this is alpha. So this is going to be 1.9 for that bit. This bit's 1.5, and to find alpha, it's the tan of alpha. So the tan of alpha is equal to opposite over adjacent, and that gives me an alpha of 38.29 degrees when I work it out. Okay, so that's those two ladies. You do these two now.